We continue neetcode, and today is the following. Let's share our screen and let's go. So we see that we finalized two topics, and today we start with a stack topic. So let's go. All right, so it's easy task, so we should actually solve it quite quickly. So it's called baseball game. You are keeping the score of baseball game with strange rules. At the beginning of the game, you start with any empty record. You are given a list of strings, operations. Operations you must apply to the record and is one of the following rules. So an integer x record in u plus record in u scores, that is sum of the previous two scores, d record a new score that is double of the previous score, invalidate the previous score, removing it from this result. So for example, we have 5, so we add 5 to the record, okay, then add 2, then we have C, all right, so C it's invalidate and remove the previous score, so record now is 5, and then D, so D means double, so we multiply, and then plus, so plus record new scores, that is sum of the previous two scores. Okay. And yeah, so we have 15 to the record. And the sum of this one. Okay, so idea here is actually we are going through operations and we just have a stack of integer vals, new stack. Then we just go through our operations, and here if for example plus equals to s, it means we should put on the vals vals pick plus integer value of s. Okay, else if d equals s, record new scores, it is a double of the previous score, double. So we just add vals. Here we take peak, so we take previous score and we multiply by 2, and then else if c equals to s, invalidate the previous score, remove it from the record. So we just do vals pop and else we just add vals and we add in this value to the score, and in the result we have integer result, and here we just while vals is empty not false, we just add vals pop and return the result. Let's run. Equals, yeah, we should just write equals correctly, then it should work. All right, so method pick. Cannot find method pick. Variable walls stack. So in stack we have pop and pick. Pop. Maybe like pick. Okay. So here we have plus, right? So record a new record. A new score that is the sum of previous two scores. So here what we should do, yeah, so we should do whilst pop its previous, and then previous one, and then we should do like previous two, let's pick, and then we should do whilst and p1 because we pop it. And here what we should do, we should p1 plus p2. And that's it. Yeah, it looks like just a very simple simulation problem. Okay, so let's go with parentheses. And we should check if valid parentheses, so given string contains just characters. So with different parentheses as an input string, and determine if the input string is valid. And input string is valid if it's like just this parenthesis. So we should check, for example, yeah. So we put onto the stack open parentheses, and when we see the closing one, we should check if they are correct. So how we do this? So we iterate. So we have our stack. Let's say stack of string. Then what we do, we have let's say not string but character. We have our character as to char array, and then if c is equal, for example, to closing parentheses, yeah, so we should so we should check if on top of stack we have correct one. So we can check like if it's closing parentheses and stack is empty, not. First of all, yeah. So I think if it's closing parentheses, then we should check if stack is empty. Or stack pop not equal to open parentheses, then we return false here. So we can, I think, add it here and add it here. So we just return false. And the same, I think, we can do for all these three parentheses. Here it's open. Yeah. And for all other parentheses, we just stack push C. And now we should return if stack is empty. Let's run. Return output false. So we have C, right? Then we have closing one. Stack is empty. No. Stack pop. Oh, okay. So I think we should go like this. Else if. Else if. Else. Yeah, it's interesting here, like why we have false, and here for false we have, okay, so we always have false. Push, what if we do add? Okay. Okay, so let's go. So here we have open parenthesis. So we should go here and we should put onto the stack. Then we have closing parenthesis, right? And we are checking here. Okay. Yeah, so the problem here that we again push into the stack. So what we should do here, it's actually when we have this one, right? And after we, if we meet this if, yeah, if we meet this if, then we return false. The same here. It should be go like this. This if should go here. And then, yeah, unfortunately, it's not really beautiful. Like this. Then instead of we have if. And yeah, and here we have actually else block. So else block moves here. And let's run. And yeah, so here we don't need. Let's run. And let's submit. Yeah, so works like this. Let's check what we have here. Yeah, so pretty much the same, right? Contain stack push. I don't understand why we need set here. Okay, so we have also map. Yeah, we can do it with map, but yeah, I think this is more simple solution. So let's go to the next one. Implement stack using queues. So what we should do here, we should implement a stack using queues. Implement a LIFO stack using only 2 queues. The implemented stack should support all the functions of normal stack: push, top, pop, and empty. Okay, so push, yeah, understood. It's like push on top of the stack. Top, it means we just returned the top value. Pop, we are popping, and empty, it's middle, we are checking it, so is this value. All right, so then we have queue, implement or LIFO, last in, first out, using only 2 queues. Okay, only 2 queues. Why do we need 2 queues? So let's try to implement. So we have a queue of integers, new linked list, and on queue what we can do, so we can push queue add x, right, and queue pop. Queue pop. Yeah, so we should do like pop from first pop. Let's check our queue Java functions. What we have in the queue, let's check. Okay, so in the queue we have remove all, remove if, remove, and all, for each, add, insert the specific into the queue, if possible to offer, insert specific elements into the queue if it's possible to do so immediately without violating capacity, retrieves and remove the head of the queue, okay, poll, retrieve and remove the head of the queue, or returns null, okay, pick, offer. All right, so and insert specific element to the queue, and here offer. So not actually much functions we have in our queue, right? So we have add an offer, throws exception, and return specific value, and remove, and poll, and element, and pick. All right. So how it actually works? So with queue we have operations like this. So we put